or in war. The continued responsibility and survival of this nation depends on the intelligence and discipline of highly trained men and women, advanced research and development, and technically superior weapons. The Navy's free-fall program, based on this concept of superiority and preparedness, began early in 1961, when the Naval Ordnance Test Station at China Lake, California, received an assignment from the Bureau of Naval Weapons to initiate the free-fall bomb development program. The first task, a retrofix program, was to update and improve obsolete World War II stockpiled bombs for compatibility with high-speed jet aircraft and new tactical delivery techniques. The second task was to develop a new series of air-launched bomb-type weapons. These new weapons were to be the most efficient, destructive, and tactically versatile of any systems yet devised. The objective of these programs was to increase the efficiency and effectiveness of the operating fleet's tactical aircraft striking power. The retrofix effort was concerned initially with three types of old bombs which required immediate modification: the ANM-81, the ANM-57, and the ANM-88. One of the first problems to be solved was how to adapt most expeditiously old-type bombs for use on new multiple bomb racks. The solution? A newly designed lug compatible with the MBR. The new lugs are attached to the bomb with steel straps. These lugs have maintained strength integrity in tests to maximum loads of 13,000 pounds. Assembly is simple. Lugs are positioned, straps tightened, then secured by crimping the seals. With this retrofix, bombs designed for use with World War II aircraft have been converted for use in today's modern naval air arm. Another modification project, undertaken by Knott's engineers, involved the low-drag Mark 81 and 82 bombs. Retrofix items which were designed and tested include a governor arming vane for the nose and tail fuses, the arming wire retainer band, and the 1.7 caliber fin sleeves. The most important of these items are the governor arming vanes. Due to increased release speeds and fixed paddle blades, the old fuses on the Mark 81 and 82 bombs would arm within 0.6 of a second, or approximately 15 to 20 feet below the aircraft. This hazard to safety was eliminated by the development of a new and effective control mechanism, which arms the fuse at a safe distance from the aircraft. The new arming vane utilizes air drag and spring tension as counteracting forces to control the pitch angle of its paddles and consequently the rotary speed of the vane. The new vanes give constant arming times at aircraft release speeds from 250 to 600 knots. An entire family of vanes is used to predetermine a variety of arming times, from 2.25 to 10 seconds. These result in a safe vertical separation distance for different weight bombs. The marginal stability of the Mark 81 was another problem. This was solved by the development of the 1.7 caliber fin sleeves, which are fitted over the old fins and secured, thus providing increased flight stability and bombing accuracy. The major part of the free-fall program has been devoted to the design and development of new advanced weapons. To date, this effort has created Rockeye, an anti-tank, anti-personnel cluster bomb; Snake-Eye, an entirely new bomb retardation concept; Gladeye, a unique dispenser for a large variety of ordnance payloads; Sadeye, an anti-personnel, low-drag cluster bomb capable of extensive area coverage; and Weteye, an anti-personnel GB or VX chemical bomb designed to carry greater agent payloads with improved dissemination. Let's take a closer look at these 5 new weapons. The Rockeye Mark 12 anti-tank cluster bomb, weight 800 pounds, 90 inches long, diameter 15.75 inches. Rockeye's power punch is 96 6-pound shaped charge anti-tank bomblets with vane arming nose fuses and folding fin assemblies. Rockeye's major units, all interchangeable between weapons, include the fiber nose cone with an integral blast screen. Retro-rocket exhausts impinging on the blast screen provide the necessary force for case bomblet separation. The ejection mandrel, consisting of 8 ejector beams and 6 woven nylon bands. The Mark 16 Zuni rocket motor, which supplies the power for case separation and bomblet dispersion. A 35-inch span stabilizer assembly with detachable fins. And the case, which houses the 96 bomblets, the ejection mandrel, and motor. After the case is separated, the ejector beams are forced outward by the rocket motor, dispersing the bomblets outward at a radial velocity of 10 feet per second. Unpacking and assembling this bomb is easily and quickly accomplished. The weapon is compatible with all 14 and 30-inch bomb racks. Highly effective with its 96 bomblets, Rockeye's impact pattern assures a maximum kill probability. Snake Eye, a retarding tail mechanism for the Mark 81 and 82 bombs, provides naval jet aircraft with a low-altitude, high-speed bombing capability, which eliminates danger to the delivering aircraft from bomb fragmentation. During investigation for the best type bomb retardation system, many devices were studied. All evaluated and rejected for various inherent problems. Out of these studies developed a drag brake tail assembly device which provided simplicity, hazard-free operation and handling, no maintenance, and low-cost manufacturing. Snake Eye is presently designed to fit the 250 and 500-pound warheads and is dimensionally the same as standard tail assemblies. The versatility of its tail mechanism, either open or closed, provides 2 types of accurate delivery modes at speeds ranging from 250 to 550 knots. The pilot, by merely selecting the correct arming switch position, can choose a high altitude drop utilizing Snake Eye's low drag capabilities, or a low level drop utilizing high drag capabilities. When in high drag position, Snake Eye dive brake type flaps on the Mark 81 are open to a diameter of 54 inches, affording maximum retardation in flight. Tests have shown that the dispersion of the retarded Snake Eye is as low as that obtained from a clean shape. It exhibits reproducible ballistic characteristics, features unique to this retardation device. Some of the tactical advantages of Snake Eye can be well illustrated by this representative animation. An aircraft carrying Mark 81 bombs, flying at 1,000 feet, would be exposed for a considerable distance to the enemy's radar sweep, and also be more vulnerable to anti-aircraft weapons. If the bombs were dropped from 1,000 feet, they would have to be released over a mile away from the target, greatly reducing the delivery accuracy. With Snake Eye, an aircraft can operate effectively at only 150 feet, well below the enemy radar sweep and anti-aircraft fire. Because of the extremely high drag, retardation bombs can be released just 1,500 feet from target. Yet, in less than 4 seconds, the aircraft will have passed the impact point, clear of any fragmentation hazards associated with low-level drops. Because of Snake Eye, new tactical bombing techniques are now under investigation. One of the most universal of all the new free-fall weapons is Gladeye, developed to meet naval requirements for an all-purpose dispenser of stockpiled ordnance. This modular-type system has a versatile capability for dispensing a wide variety of loads, including chaff or leaflets, lazy dogs, chemical and biological bomblets, and other small munitions, some in existence and some now being developed. Easily and quickly assembled, the canisters latch into position automatically. With a length of over 9 feet, Gladeye consists of 7 identical cylindrical sections called canisters, 14 inches in diameter and 10 1/2 inches long. Streamlined nose and tail fairings are attached to the front and rear canisters. The upper portion, the strongback assembly, to which the canisters are attached, houses 7 ejector units. Each ejector is actuated by 2 Mark II Mod O ejection cartridges, which are fired by an electric current sequenced by an intervalometer. The intervalometer also provides for 4 modes of ejection: single, individual canisters fired by the pilot; slow salvo at 300 milliseconds; medium salvo at 100 milliseconds; and fast salvo at 50 milliseconds. After the mode has been determined, the selector switch is rotated to the arm position. The ejection time interval and arming of the weapon are set prior to takeoff. Canisters are ejected from the rear forward. The ejection modes provide flexibility for individual canister ejection or rapid salvo. The strongback is retained for subsequent reloadings. Depending on the type of ordnance carried, individual canister weights will range from 33 to 200 pounds. This will vary the total weight of the weapon from 480 to 1,600 pounds. If leaflets are used, 12,500 can be packaged into each of the 7 canisters for a total of 87,500. Gladeye has the carrying capability for 98 M134 chemical bomblets, or 35,000 lazy dogs, 41 caliber sub-missile steel slugs. Providing a variety of employment tactics, this new carrier dispenser concept for ordnance, as well as for advanced munitions now on the drawing boards, is a versatile, highly effective weapon. The 4th new weapon is Sadeye, the Universal Dispenser Bomb, Mark V Mod O. Primarily designed to inflict heavy casualties over large areas, it can carry in its weather-tight container large payloads of special anti-personnel munitions. Dropped from Sadeye, these special munitions produce a circular ground impact pattern covering several hundred feet in diameter, with a resulting high casualty ratio. Sadeye is also an effective dispenser for bacteriological and chemical bomblets. Split longitudinally through the center, the Sadeye dispenser was engineered for ease of production and reliable operation. The internal mounting of the arming wire is an important safety feature. Inside the bomb, it is safe from external hazards, such as mishandling or withdrawal forces exerted by the airstream. The nose section of the bomb is secured by a nose locking ring. This ring holds a fuse with a wide time delay range, which is preset on the ground for desired functioning time after release. The bomb case is held closed and supported by high-tension steel suspension bands during storage and flight operations. When the bomb is released, the suspension bands snap off, cleanly separating from the bomb. As it falls, the delay cycle is completed, and the actuator cartridge behind the fuse blasts the locking ring and fuse forward. This action unlocks the bomb halves from the front, and they are ripped apart by the airstream, instantaneously dispensing the payload. Aerodynamically designed to be carried in excess of Mach 1 and delivered at air speeds up to 600 knots with any of the standard bombing tactics, Sadeye has a highly predictable ballistic trajectory coupled with a wide variety of munition loads. The fifth I bomb is a completely revolutionary concept in massive chemical bomb weapons. Weteye, developed to increase the lethal payload and improve the dissemination of chemical agents, will be highly effective against personnel in open terrain, armored vehicles, field fortifications, underground shelters, and ships. Keystone of Weteye's uniqueness is that it is formed from the largest extruded aluminum shell ever produced. This tubular shell, with a wall thickness of only 1/8 of an inch, is almost 7 feet long, with a diameter of 14 inches. The tube is shaped and formed into an ogival nose and boat tail configuration. The advanced techniques in metal forming, which accomplish this, eliminated all longitudinal welds. Thus, leak integrity, compared to other bomb designs, was greatly improved. In addition, the empty bomb weight was vastly reduced. Placement of the strong back on the exterior of Weteye eliminated all exterior welds in the strong back area and provided additional agent volume within the chemical chamber. Weteye is designed with folding tail fins for compatibility with the MBR. Total fin span when open is 34.9 inches. This feature permits 6 Weteyes to be mounted on a single MBR. Weteye's filler plug is designed for automatic, remote agent loading systems. It incorporates 2 soft aluminum balls, which are placed into the tapered filler closure port, then seated tightly under high pressure. This provides a leak-proof system which has not failed in over 100,000 leakage tests. Weteye's metallic nose cone provides covering for the M990 electric fuse, as well as protection against high-frequency radiation. Interim airburst requirements for this weapon will use the M913 electric proximity fusing system. 4 17.5-inch long, linear-shaped charge sections housed in the burster tube assist in dispersing and aerosolizing the liquid agent. The use of linear-shaped charges in chemical weapons is a new and highly successful concept for obtaining greater area coverage with more uniform concentration levels. 8 linear jets are produced by these charges. Another unique feature of Weteye is the stabilized center of gravity. This is achieved by a void control system, which reduces the liquid shift caused by attitude changes. Weteye is loaded in a vertical position, with the forward compartment completely full. The rear chamber, separated from the front by a sealing bulkhead, is left with a 10% void. This void remains in the rear compartment regardless of bomb attitude, because a void control orifice is always below the level of the liquid. But during temperature expansion and contraction, the orifice permits the liquid to flow freely from one compartment to the other. The application of this principle results in increased free fall aerodynamic stability for the weapon. Comparing weight factors and volume capacity of chemical bombs, Weteye's empty weight is 177 pounds. Agent payload, 368 pounds. Total weight, 545 pounds. The Air Force MC-1. Empty bomb weight, 490 pounds. Agent payload, 220 pounds. Total weight, 710 pounds. The Navy Mark 94. Empty bomb weight, 333 pounds. Agent payload, 108 pounds. Total weight, 441 pounds. This ratio of payload weight to bomb weight points up that Weteye carries 69% of its total weight in payload, while the MC-1 carries 30%, and the Mark 94, 24%. Weteye's unique engineering concepts: one-piece tubular construction, folding fins, void control system, high volume capacity, and linear shaped charge for agent dissemination result in a weapon which greatly increases the Navy's capability for chemical air attacks. The free fall program has just begun. For in this mid-20th century, each day, the need for limited warfare weapons becomes greater. We are meeting this need with new, advanced free-fall weapons: Snake-Eye, Sadeye, Rockeye, Weteye, and Gladeye. And even newer weapons are now under development. Weapons which, when added to our already existing arsenal of freedom, will make this nation even stronger in its resolve and more secure in its beliefs that peace can and will be maintained.